In the homework, it tells you to use the graphic calculator for that. So you're supposed to use it to find the x-intercepts and to find the critical numbers. And to find the possible points of inflection. So I'm not going to worry about these. Whereas you have a picture of the calculator, you should use it. Yeah, without a calculator, this is super annoying.
So there's not going to be one of them on the test?
No. You may have to do some stuff, but not, this one is frustrating because the two x-intercepts are irrational, and the two critical numbers, well actually the critical numbers are nice, but the two possible points of inflection are very irrational. And then testing it is very annoying. So there's too much of it that is very tedious. I didn't ask you for this, but it's there. It's number 4. So the information on number 4 says the slope of a graph is between 2 and 4. Remember I told you, don't forget that the derivative means slope. So I substituted f prime for m to make it easier for you maybe. If the slope of a function is constant, then the function must be aligned. Right? So f of x could be 2x plus 3, or 3x plus 3, or 4x plus 3. Why does it have to have the 3? Because you're given f of 0 equals 3, so that's the y-intercept. No, that's given. And then the question is, there's many more equations. You could have one with the slope of 2.5x plus 3 and so on. But the question is, for whatever lines you have, whatever the function is, what would be the smallest y value when x is 2? It would be this one. If x is 2 for this one, you would get 7. And if the function is this one, 4x plus 3, and you plug in 2, you would get 11. So the greatest y value would happen when the slope is 4. The y value of 2 is 11. And the smallest would be when the slope is 2. It's number 4. No. It says think about it. It makes a lot more sense when you're looking at the book. You got to look at the question of the book. All right, let's move on to the next. Pick one from the graphic. Try to do different ones. Oh, I got another one. I'll make one up if you want me to.
It's one column, one graph.
Yeah, I'm thinking of whether it should be 1 or 2. It's just that one. If you're uncomfortable with that problem, they mix it all together. If you have another one.
Yeah, then he waved the sand.
Yeah, change this one. It looks like the previous one with a big difference, right? What's the domain for this one?
X is greater than
Like that, right? Or,
Hey, Vic.
yeah. Either way, it means the same thing. To state a domain, you could say what it cannot be or what it could be. So what's happening between -2 and 2? Nothing, right? Nothing. There is no graph between -2 and 2. Right? That is very important because that'll help me right away with the x-intercept. What's the x-intercept? Well, the x-intercept would be 0, but I can't use 0, so none. You understand?
Damn it.
The domain is very important. In this case, it eliminates the x-intercept. And if x cannot be 0, then there is no y-intercept either. In order to find the y-intercept, x must be 0. But it can't be. Okay, yeah. So now we just need the derivatives. Wait.
Yeah, that part I understand.
We do have two x interceptions, sorry. We don't use 0, but we have negative 2 and 2. Right? No 0, but negative 2 and 2 are x interceptions. Sorry. Okay, let's go to the derivative. Alright, no more mistakes, right? What is the derivative? Of the square root of x minus 4?
1, 2x.
Radical 0 is 0, right?
What?
Radical 0 is 0.
Radical 0 0 what?
Radical 0 equals 0.
Yeah.
Now that part I don't know.
Oh, because it's the derivative
Yeah,
formula.
Squared
Yeah.
plus x squared minus 4, right?
Hey, Jackie, okay, Bob?
Okay.
Yeah, is he walking over?
You may be wondering why I'm stopping, right? Maybe not. They're out of the domain. Yeah, I guess so. 2x squared minus 4 equals 0. X is equal to plus or minus radical 2. But
No, but then
this one don't belong to the domain. Well, is it derivative, right? No, I'm not sure. So x plus x is x squared, and this is plus x squared minus 4. X squared minus x squared is 2x
I
squared.
get everything until derivative.
Yeah, this is pretty much like a review right
So
now.
I'm thinking this one is
Except
not
for
going
the
to have
derivative.
extreme.
That's the only part.
Put it on. Okay. Okay, I need some help. Okay, I need some help, so I think I'm going to have to go with the limits at infinity.
Oh my gosh.
Yeah, this is confusing me. The limits at infinity should help. I need to know what happened at the end. See, there is an end. I need to know what happens there, so let's go to that. So, limit as x approaches infinity. So if I put infinity, I get infinity. That's easy, right? Infinity times infinity is infinity. Okay, so now I know this one should go up.
no, but subject.
All right. And the other one is the same thing. As x approaches negative infinity, you're going to get a negative. Well, since you guys are still confused with this, I guess I'll do a little more work with this, with the limits. Just substitute it. This particular one is really easy. You just put in infinity, and then infinity minus 4 is infinity times the square root of infinity. Infinity times infinity is infinity. And this one would be negative infinity outside, but that one is infinity because of the square.
Yeah, I like
So
the
this would
infinity.
be negative
Yeah.
infinity. That really helps because I think that's pretty much all we need. There is an x-intercept at 2, another one at negative 2, and so the graph has to start there, and then it goes down. So it should be like this, maybe, or maybe like this. Maybe I need concavity, so I'll use concavity.
I kinda-
Is it that or is it this?
Pluck in a point.
That we actually don't know yet, because both of them satisfy this. Yeah, both of them are going to negative infinity. So I'll use the second derivative to determine if it's concave down or up. The other one too. The other one goes like this or like this. So
Okay, I got that part right.
yeah, but we still don't know. It's still all negative, so it's still
Yeah,
going
I
to
don't
negative
get the-
infinity. It's just
I
approaches
just
zero.
plucked in a few points
Yeah, I
and
think
I
it
know
would be
where
this
it
one.
goes.
Okay. So where's my first derivative?
The derivative helps you find like the extreme and stuff.
Yeah.
Okay. Second.
I think we're just gonna run out of batteries.
Like that, right? I think I need more space.
I guess plugging in no point is faster. I don't know why I did it in my head, but
You could. That could work too.
well, that always work unless you do something with your calculation.
Yeah.
That's x squared minus 4 times that is 4x cubed minus 16x. And this one is minus 2x cubed plus 4x. Is that right? There's an x here times that is negative 2x cubed plus 4x. And the bottom has a 3 halves. I'll do that in a second. I'll simplify this. This is 2x cubed minus 12x.
So
Right?
half an hour just to do one problem.
Well, it's a couple other problems too, but yeah.
That's gonna be hard, huh?
The bottom is always
Just long.
positive, so the
Takes
only
a
one
long
that
time.
matters is the top. So if you put in a number, yeah.
You go to 0.
No, now I need to analyze my second derivative. If I put in a number smaller than negative 2, like negative 3, this would be bigger than that, so it'll give you a positive there and a negative here. Actually, I needed the concavity, right? I already know that. I need the concavity, so yeah. X equals 0 and plus or minus radical 6. That one is okay. That's good. There shouldn't be points of inflection because it's kind of strange. It would be like this, like this.
Oh, obviously. Plus minus 2 doesn't work. Just click whatever.
Yeah, so I'm not even including that. Check the second derivative.
Just for you.
I need to check. So what's this equation? X square root of x squared minus 4.
What the heck? I got yes.
Yeah, I guess that's how it looks. The way we thought it would look at the beginning. I'm confused about the point of inflection.
Chair right there.
It just doesn't seem like there should be any.
Wow, okay.
Is the second derivative correct?
That's right. That's right.
Unless it changed later, but no, it just can't.
It could. Anything is
I
possible.
see a little curve on my.
Although we're not gonna give you as complicated as that.
Sure.
Okay, let's see.
Like super actually.
So what's wrong with
Rotated
those
1 degree.
points of inflection? Well, I guess there's nothing wrong with it. I don't know why I just have to test it. Okay, sorry. So I'll put negative radical 6, which is about negative 2.4, and radical 6, which is 2.4. If you plug in, you can see it right there. If you plug in a number to the left of that, like negative 3, this would be positive, and that's negative, so the answer is negative. And if you put negative 2.1, that would give you a negative there also, right? And that's positive. That's the part that. What's wrong with not? Why can't I?
Wait, you don't need to plug anything in between because that wouldn't matter.
Yes, it does, because it could be a point of inflection. It could go like this. It could be like this, and then like that. Okay, see the information that is there's something here. So yeah, according to that, it would be like this. Maybe it is like that. Maybe the calculator's not giving us the right info.
That's like a
Yeah, the
small
calculator,
curve.
I guess you can't trust it all the time.
No, there's a small curve. It's like a 1 degree.
Yes. Okay, I'm gonna ignore the calculator and just. Okay, so, and then this one is what? This is also plus, right? No, this is minus, this is plus, right? This is backwards. If you put 2.1, this would be positive and that would be negative. Yeah. 2.1 is 4 point something, minus 6 is negative. So you get a negative and then positive. All right. So it's concave down and then up. We would have to find the y, but we're not going to worry about that for right now. So let's go back and graph this. I made a difficult one. Put on. Okay. So what is it? Is it up and then down?
It's down and then up.
It's up and then down. Okay. And what again? Up, down. Okay. Up, down.
Oh, yeah. Oh, yeah, that's
And this one is down and up. And the part that it changes is radical 6. Right here, negative radical 6. Make it a little bit
Okay,
better.
now it's making
And yes, we would have to find the y. All right, wow, that's pretty weird. I really wanted to explore a different one. This one is really different. So,
I'm really confused.
one thing
about
that
the
was
ribbon.
very important right here was the limit at infinity. Those are very, very important because it told us that at least we already knew that it went up like that, right? I would have not guessed that it had a point of inflection, but it did.
So we did. We used the graph and we didn't say.
I understand the infinity.